sorry. This was part of the template. So. Okay, so this is the title of this talk. I'm not going to read it. You can read it yourself. So there's this idea in my mind, which is a question. And I really don't have an answer for this question. So I'm sorry if you were here for answers. Because, so landscape, technologically speaking, in the area of data warehousing has changed a lot. But some practices has remained the same. So are we doing the right thing? So are we doing the right thing where we don't question our practices, considering that everything has changed? Now this is the question, right? This is who I am. I'm Matteo. I'm a data engineer. I work at Laser Hub, which is a platform for procurement for digital for metal parts. I hail from Milano. I used to live in London. I live now in Tübingen. I've been practicing databases for 18 years and data warehousing for 12. Just read the slide. So this is the question for you. Okay, this is a fairly, I think, important question to ask ourselves right now. I want to add now a little bit of context about dimensional modeling and data warehousing, so we are on common ground and we can go from there. So this nice fella here is Ralph Kimball, and he wrote this book, which we all know and love, and we have read from cover to cover. Now, please notice that the third and last edition of this book has been published in 2013. Which is 9 years ago. 9 years ago, for comparison, Redshift was released for the general public. Okay? 9 years is a lot in the terms of technological landscape. In his book, he popularized or invented, I'm not sure about this, the notion of analytical modeling. So basically transforming transactional data for analytical purposes, for data. And he went with this thing, with the thing we call the star schema, right? So why the star schema? I mean, what was the reason behind this kind of data model? We can find a bunch of reasons for this. So there's a cost reason. We go through those reasons in a while, but these are, I think, the main reasons for using dimensional modeling. And of course, these reasons have remained the same, even if something has changed recently. There are also other reasons for using this star schema. You can read here. So it's mostly about basically simplifying the data model from a transactional side of things, which is mostly used by machines to interact with the database, to a human side of things, which in the idea of Ralph Kimball was to offer analysts and all people in the business a way to interact with the data that was more human-friendly rather than machine-friendly. So I tried to come up with an alternative, but this is not a solution to the changes. This is not a proposal. I'm not trying to sell anything here. What I'm doing here is just to try to make a comparison. So I come up with a simple alternative, which I call the wide table, or the one big table, which basically means that instead of having a star schema, we denormalize everything in a huge table, okay? And we compare. We'll try to make a bit of a comparison. Now, this comparison is not exhaustive because there's no time for this, but it's a start, just to question what we are doing here. Now, let's see costs. Of course, now you might be aware that costs have decreased a lot. Okay, cloud computing has enabled something that wasn't really a thing a while ago, because storage now extremely cheap. I'll come back to this later on because I think it's very important because it changed things on other sides of the data thing. But basically, costs have decreased a lot. And now, columnar data warehousing, it's a thing now, which means that we can compress data very effectively. The thing with back in Kimball time, they were using databases which were born for transactional processing for analytical purposes, which means that they were row-based storage for analytical purposes. Now we have column-based storage, which means that we can compress data very effectively, which wasn't a thing back then. And then one thing about cost is that modeling data using star schema is very expensive because it takes time and it takes expertise, and both these things are usually quite expensive. So this is cost. Performance. Now, this is just an example. It's taken from an article you can find on internet, which is basically comparing queries on a star schema and on a wide table on BigQuery. Okay. Now you can see that basically the average improvement using a huge denormalized table, it's almost 50% query response time. This includes, of course, compilation time, and caching is disabled, otherwise it wouldn't be fair. So I think speaks pretty loudly in terms of where we are with performance. And last thing, this is a bit more subjective, I think, because it's about understandability. Now, the thing with star schema is it's easier to comprehend, okay, for business people, sales people, every kind of stakeholder in the company. But there's still something to learn about star schemas. Okay, there are some concepts that need to be explained, and they're not super intuitive, at least for like non-technical people, nor not analytical people. For example, the distinction between fact and dimension, the concept of surrogate keys, what granularity is, joins, because I mean, guys, come on. We all know how to make a join, but it's not something that snaps in your mind. You need to use sets and to explain how sets works, and it's a bit. You need to have a bit of background on stuff like that. And of course, one big table, it's easier to model, as I said before, which means that you save on time and cost. And I think that using an approach like this, it helps people understanding better the data, and it helps what we call a democratization of data. So I think it's not the first time you hear this term, right? We want to democratize data, which means that everyone in the company should be able to use the data, okay, fairly easily, without doing training, without explaining how SQL works, without just. So if we use a paradigm they are used to, which is basically saying, yeah, look, this is like Excel. Everyone knows Excel, right? Everyone is familiar with Excel to some degrees. Then it's easier to take them to the next step and explain how they can run their own analysis, how they can own the data for themselves, take informed decision, and all the stuff that we want to do. So I think this is an important step if we really are committed to democratize data across companies. Think about the past. Now, this has happened a while ago. Remember when there was no ELT? Everything was ETL. Why? Because storage was expensive. So we couldn't just pull the data and keep it forever, completely untransformed and stuff like this. We had to transform it because storage was expensive. So, and then no one really questions this DLT approach anymore because it's so convenient to have the raw data there, always available, If we need a new column, if we need a new measure, everything is there. We don't need to change anything. We just pull the new data, add aggregations, transforms, and stuff like that, and then we have the data ready. So if you think about this, the paradigm has changed not a long time ago, and no one is really questioning this change anymore because this new approach is extremely convenient. So what's next? I don't know. I really have no idea, and I'm sorry. But is the one big table or the white table a solution? Possibly, or maybe not. But maybe it's just that we start thinking that it might be the time for a slightly different approach to data modeling. Most of us work in a startup, so we know how being fast is important and how we should keep agile, iterate over and over and stuff like that. So maybe it's time that we start iterating on this concept of data modeling. There's one thing I forgot to say, that the common star schema, the data model itself, it's quite rigid in itself. I mean, you can always change things, but it takes a little bit of effort, a little bit of time. As I said before, this is expensive in terms of time and cost. So, and also, I would like to say it again, think of the end user. Think of the people that are going to use your data. You want to be able to meet in the middle, to offer them something that it's ready to use or slightly easier to approach. And you need to also go through rethinking data modeling for this. One last thing I would like to say is, if you think about it, it's not only about the ETL, ELT thing I said before, but if you think about it, this is happening already. Because I'm pretty sure that even if you try to be as disciplined as possible about modeling data in a star schema, sometime, maybe not all the time, but sometimes, we take little shortcuts. We try to make it, I won't say, yeah, maybe shortcuts is not the right word, but we try to make it easier for us to use, and also we try to make it more tailored to our situations, to our, I don't know, business case, or to whatever you may think, your situation overall. Maybe it's your data stack, maybe it's the people that are going to consume the data, but everything you do with data modeling, usually it's a compromise between what you're trying to achieve and keeping data in a usable and actionable form. So this is happening already. You need to just realize it. So these are the credits for this talk, because it was inspired by a guy named Dave Fowler, and the performance things came from an article by this guy called Michael Kaminsky, and of course, Wikipedia. Questions? Well.
So I understand your talk more preparation for Q&A anyway.
Yes,
it's like
absolutely.
half a question,
yes,
and half a thing. Sorry to be the guy who has 2 points straight away, but the first one about Michael Fowler and that article, how exactly is Fivetran writing those things, and how they approach stuff with doing, and they're looking at famous large data set, the way that Fivetran generates data, and I would say Fivetran are great, but like right up all through their tech layer, they're pretty ignorant. But it's an interesting thing, and it happens. Businesses, you have nothing to model. They move a lot of data, but they never have to do anything because they are tiny. And the thing on top of that about the one big table, the big table is essentially star schema followed by flattening. Difference, except for the fact that go to ask, well, updating becomes incredibly difficult, and that was all based on select, as far as I recall. stuff that you might have to do about updating. About BigQuery and their first iteration of BigQuery, they said, oh, you never need to update anything, and it's insert only, and it's fine. And then they were like, oh, apparently no customer in the world thinks that's reasonable, so we're going to introduce version 2.0, which has. And lastly, one big table doesn't really, all the stuff around slowly change dimensions, it solidifies slowly change dimensions in terms of it'll happen to that user when they're in place. Now stuck. You want to say, where do our most valuable table doesn't look solidified? That customer lived in Germany when he bought that thing. Now all your good customers would have serious difficulty. Okay, that wasn't really any question. I don't know if you have any comments on those things.
It makes perfect sense. So, of course, the Fivetran article was just an example how if you skip joins, you get some performance advantages. On the other hand, what you say is true. I mean, you can obtain a big table by just flattening your star schema. What I was suggesting is keep the star schema. So keep the data modeling part, at least partly, and instead of having a star schema behind your white table, just have your data behind the white table. Now, sorry, I finished this. This is all very vague, I understand, because it's, again, as I said, as a disclaimer, I really don't have an answer to it. I'm just posing a question because I would like to understand if maybe it's time. I think it is, but I would like to understand, to see to go beyond a little bit of this thing.
Okay, I will pose something here.
Yes.
And it's kind of funny as well because I actually wrote some stuff for Fivetran.
Okay.
I've written well for them, and so clearly the people who write there have no idea what they're talking about. But one thing I think that really happens in the modern context, and you sort of got at it as well, is there's a big confusion about what ELT is. I think a lot of people, not one big table, but a lot of people just dump the data and then brute force it. And I would call that ELA, extracting, loading, analyzing it, brute forcing, using the technologies we have. And I think in the modern context, what I found useful is a blend between extracting, loading, analyzing, which is allowing an escape hatch to brute force an answer right now, then being respectful of going back to actually transform this for the longevity you get from data modeling.
But absolutely, transform part is mandatory. I think.
But you can temporarily skip it sometimes, and then you say this thing was temporarily skipped. Do we need to property model it, or do we dump it?
Yes.
You know, talk too long.
Thanks for the presentation. For reporting, I think that one big table actually is a lot. But you mentioned about a lot of pros. What do you think are the cons about one big table?
Yes. I haven't really reflected on this. I still think there is a bit of value in, I'll answer like this. I still think there's a bit of value in modeling data using a star schema. What I wanted to try to convey is that we need to rethink about this. So I want to say let's stick with a big table or let's stick with a star schema. I want to say let's try to go beyond this. There are pros with star schema. So I think that it's a proven method. For example, it's been going on for a while, and it proved that it was needed and it was useful. I don't know. For some people, it might be easier to understand, and I think it's also easier to understand for us because we have the discipline to understand it and to properly use it. Honestly, I don't know if there are cons on the one big table. Maybe it's slightly less, slightly more. It's a bit. Honestly, I don't know. I stop here because I don't want to add anything.
Or maybe let me rephrase. How do you explain a table of 200 columns, for example?
Sorry?
How do you explain the logic of a table of 200 columns? If a table is 200 columns wide,
Yeah, no,
how do you
that's
follow
right.
the logic
Yeah,
of
for
that?
example, that's the thing. So at 200 columns, yeah, I think you could address another thing. For example, you have, instead of having one big table, you can have more than one big table, slightly smaller. That's the thing, for example, yes, that's a perfectly valid point. Yeah, 200 columns. Or maybe if you're using some sort of front-end technology like Looker or Tableau, you can filter down the one big table just by showing columns people are interested, maybe doing some smaller data sets for business, different part of the.
Anything where you need a process of updating or something that would cause a self-join. You just created often a massive table that's very good for insertion behavior, very good for read behavior. If you need to go back often with hyper large flat tables, or you need some sort of self-join. There, I think.
One that I would add is the value of having the star schema flattening is that you kind of force yourself to really be clear on what are the entities that you have in your model, right? If it's users, orders, order items, whatever else, and how they relate to each other. Because if you do that in one flat table, then it's relatively easy to create some join that creates duplicates without being aware of it, unless you kind of create tests afterwards. You have a star schema, of course, then you have primary keys, so you know your data is unique, and then at the joining, you know that you're not generating duplicates accidentally. But I think the better point is more, we're super clear on what your model looks like. It's kind of enforcing guidelines on yourself, and if you stick to them, way easier to create a huge data warehouse project in my experience. Then you flatten at the end to still give nice tables for your business people.
Maybe it's more of a comment, but I think mentioned.
I think there's a degree of transformation that you can't really skip. I mean, as he posed, it's good to have raw data because you can always transform later. You have the raw data. On the other hand, it's, for example, it's good to ensure that you have clean data, that there is coherence between the various data sources, everything is in place. You have no duplicates, for example, or stuff like that. So I think that's a bit of degree of transformation that maybe just transform the data from a transactional source or whatever source you have to something that is still, I don't know, it looks like transactional, but maybe it's not transactional, or I don't know, I really have no idea here, but which ensures that some criteria are at least met, so you can make good use of the data is necessary.
I sort of want to go in the direction of what Rinke said, essentially. See this move in the data environment, incorporate more of these established software engineering. 10 years ago, data was a fucking mess. Everyone was using these fucking notebooks. It was tedious and disgusting. Now we use version control, we use code. And I'm sort of feeling like this move with Kimball, we said these things in 2020, similar, where we all tricked ourselves consciously, saying, all right, we're not going to dump everything into one table, but we think beforehand on how to model these entities, not just as entities, but also rather as how the organization works on an abstract level. Essentially, that's what a data class is supposed to want to model of the organization. It's not tables, it's not data, but organization function, business level, right? Wouldn't this move to one big table, in your opinion, then, of reject all of these ideas and say, listen, don't use any of that, we just dump all of this in one big table. Essentially, you can just get rid of your data warehousing layer. Because we just take the data lake, combine all the tables into one. Then, in my opinion, make things actually a lot less understandable. Idempotency, get rid of thinking about what columns we need, because that's essentially all before we build these entities. And long term, make things a lot less structured, in my opinion. Is your take on that?
I don't know. Sorry, we can discuss later.
I think I have a point that goes pretty much in that direction, where trend in the fact that addresses that, which the fact that we have like stars can find independent of what. Well, behind it, something comes, for example, star schema. Set up. More of a comment.
Thank you.
Okay. That we save costs on storage. Yes, that's the main idea behind switching from ETL to ELT. But when we think about lots of things, maybe limitations, how we deal with like security level, we need to switch maybe from table level security to column level, right? If we have just one big table, or other things like dealing with, I don't know, duplicates instead of cleaning something in one table. These duplicates will result in maybe some incorrect metrics in this one huge table, so we need to go even more detailed, fine-tuning of this table, performance of basically updating all this table, and the hidden costs of maintaining all of these things. That for the end user it seems like one big table, but are these hidden costs also considered when we consider how cheap the storage is? And can't we finally get to the negative side of this equation?
This is a good point. Yeah, I think modern data warehouses implement some sort of security at column level. I think BigQuery at least. I don't know about the others. But of course, this wasn't part of the thing because I didn't really think too long about the security part of it. But of course, it's a concern. I mean, especially now, because the time of Kimball stuff probably was slightly less a concern. There were less laws about privacy and probably less threats in cybersecurity terms. So, yeah, that's my take. But I'll think about it. Thanks.
Thank you, everyone. Thank you, Matteo. Thank you all for participating and presenting quite interesting presentations that brought quite heated discussions. And I think we are then good to go for the break, and we will continue directly at 4. Exactly, at 4, 17 minutes.